Fisheries independent data collection. So this is some of the stuff that's going on at fisheries independent data collection. They go out there and they troll some nets, they measure an area, they do stratified random sampling with camera studies, they do gonad testing to see when fish become sexually mature and able to reproduce. They produce age and growth tables, really, really cool information with the camera studies. They're actually now using artificial intelligence to analyze this camera information. One of the big things that cameras do, I'll show you as we get down there, is they collect a lot of video offshore, but it takes years for someone to sit there and interpret a portion of that data. Whereas now they're trying to develop AI to actually interpret that video data in real time. So when these big research vessels, look at all these research vessels, oh look, there's a Florida fisherman, because we actually did a fisheries independent trip with them. So they use fishing boats like ours, and they use their own research vessels to go out and drop cameras and do these fisheries independent studies. So it's very, very interesting on how they collect some of this fisheries independent study. This is a very cool example, population versus sample. A population is the entire group about which information is desired. So that's all the fishermen. A sample is a representative portion or part of the population. Sampling public opinion is like sampling soup. One spoonful can be reflective of the taste of the whole pot if the soup is well stirred. So look at that. These are a very simplified example. If it's like tomato bisque soup that's very well stirred and pureed up, one spoonful is going to give you a representative sample of the entire pot. Because one spoonful, the flavor is not going to change. One spoonful or the whole bowl, the flavor is going to be pretty consistent, right? But then if you have like a stew that's not blended together, you might get one bite that has a piece of chicken. You might get another bite that just has noodles. You might get one bite that has a couple carrots in it. Every spoonful is going to change the taste. It's not a representative sample with each spoon. So you need a bigger sample size to get representative samples. So that's a very simplified kind of illustration of the problem we have is fishermen are not tomato soup. Fishermen are more like a stew. Every fisherman fishes a different way. We have different sized boats. We fish different depths. So you need a large sample size to get a representative sample of the entire population. Let's see here. Life cycles. They do a lot of fisheries independent, really focuses on life cycles. So like a gray snapper with an AY is a mangrove snapper. So they develop this life cycle of gray snapper or mangrove snapper, which they start offshore in deep water as adults. They spawn, they produce their little baby eggs, phytoplankton, which get pushed inshore. And then the babies grow up in the mangroves. Once they're about 8 to 10 inches, they start to reach sexual maturity. They swim out of the bays to the seagrass and then eventually to the nearshore artificial structure. And as they get bigger, they swim offshore, and then they spawn. This is a life cycle. This is what fisheries independent data really helps to collect and kind of ascertain. So again, the key attributes of fisheries independent monitoring or FIM surveys is they have broad temporal and spatial coverage, meaning they have a very large time frame and they cover a large area across the geographic area. Spatial coverage, time length is temporal coverage. And they're long term. So like the camera studies have been going on since the 80s. The bottom long line index started in like 1986. So they use statistical sampling designs that stay consistent over time. And that's what makes fisheries independent science so good, but also so costly, because these are scientists going out there and doing very complicated processes. You can see here, this is, I think, Sarasota Bay or Charlotte Harbor. I think this is Charlotte Harbor. Yeah. But you can see how they break it up above my head. So this is a normal satellite view. Then they stratify it into a couple different areas, a couple different estuaries. Then they stratified random sample those areas by creating grids and using computer modeling to help discern where they're going to sample from day to day. So here's inshore sampling intensity. So this is just a very quick overview of some intensity or heat maps of samples that are collected. You can see inshore wise, it's very easy to do a lot of testing and sampling, and the sample size is extremely high because it's easy to access these areas and sites. Offshore sampling and habitat mapping, you can see a lot of sites have been satellite mapped or mapped with LiDAR and sonar, and they're basically creating a habitat portfolio to help them better stratify, random sample the area through camera surveys. So this is the Reef Fish Camera Survey, G-Fisher. This is actually kind of new because they've basically created a way to compile all the camera surveys. So all these little dots above my head are different camera survey sites that they've dropped cameras down and counted fish on those cameras. And again, camera surveys are awesome. They give us a lot of good information about the health of the stock, but right now they take years to process. So a lot of times we're 2, 3, 4 years behind. That's the science is lagging behind what we see on the water. We might see a fishery doing really well and all the fishermen are like, there's tons of these fish out there, and science are like, well, maybe we're trying to catch up. And well, that's a lot to do with the time lag of some of these fisheries independent studies. But now with artificial intelligence and some of the big leaps and bounds they're making, that could actually help improve and shorten that time lag, which is very exciting information. So data collection definitely helps through all these sites. They compile all this data and they input the data from the fisheries independent science into the stock assessment. So again, fisheries independent science, fisheries dependent science, both of those scientific approaches are used to input into that complicated stock assessment model. They're starting to model some impacts from red tide, some cold weather events. They're able to kind of model some of these habitat impacts and how they affect our fisheries. Also, species distribution has species shift north, like snook are moving further north along Florida's west coast. We see yellowtail snapper doing the same thing. So they're starting to look at some of that species shift. Also, age composition is hugely important to stock assessments, meaning at this size, a fish is how many years old, at this size, how many years old, at this size, how many years old, and what's the fecundity of the fish is super important, meaning if a fish is this big, it might be sexually mature, and it might be able to reproduce, but its fecundity might be low. And that means fecundity is how many eggs can it produce. Like red snapper, for example, a huge red snapper is very fecund. It can produce millions of eggs. So that 30-pound red snapper that you catch and kill, you might have killed 6 million future red snapper. Whereas if you catch and kill a 16-inch red snapper, it's not as fecund. You're not removing as many future red snapper because it's smaller. It doesn't have the reproductive ability of that larger fish. So larger fish are very important to make sure that they get back down to bottom. If you catch one out of season, you got to get back in the water quickly. You got to use that descending device because we want those bigger fish to survive because they're more fecund, they're more reproductivity, they're higher reproductivity potential. So that's a lot of what fisheries independent science can talk about. Oh, this is just what I just talked about. One 24-inch female red snapper will produce as many eggs as many 17-inch females. So just what's that? 7 inches bigger is exponentially more eggs can be produced. So super important. They do diet studies, which is pretty wild. They basically will expel what's in the stomach of one of their sampled fish, and they take this soup and they're able to use magnifying glasses and look at jaw bones and different parts of these fish and discern what that fish has been eating, which is pretty incredible. Some of what they look at and how small it is, it's really amazing that they're able to kind of figure out some of that information. And here's some of the surveys and historical coverage. You can see how much information is being collected off the coast of Florida. They definitely do a really good job in Florida, spending a lot of money collecting information. So consistent, adaptive, integrative, and innovative. Definitely really, really cool stuff, fisheries independent science-wise. So that was one part of it, fisheries independent science. Now we're going to get into a little bit more about fisheries dependent.